Oh yeah, here we go into another very cool manipulation. In this particular mini lesson, we've got some functions involving e to the x, and e to the x is in the denominator. So we're asked to evaluate the following integral with two different techniques. So in this one here, I'm going to continue with the idea of adding 0 to top and bottom to see how we can take advantage of that idea. But then we're going to learn another technique, which is multiplying by the reciprocal, or e to the minus x, and seeing how that works too. So these are two other manipulations that would work. So I've got 1 plus e to the x in the denominator here. So I really wish there was a 1 plus e to the x up top, obviously. So first, let me factor out a 2. So that gives me 1 over 1 plus e to the x dx. Now by adding 0, and you can add 0 in any form you like, and I'm going to do this in a slightly different color here. I'm going to add e to the x and subtract e to the x. And when I do that, I have not changed the problem. We still have 1 up here, plus 0. But watch what I can now do. I can write that as 1 plus e to the x over 1 plus e to the x minus e to the x over 1 plus e to the x. Isn't that cool? I think so too. And so that's our integrand that's been manipulated. Again, splitting this up over that same fraction because we can. Now that we've done that, we'll simplify this down a little bit, and we're going to take this as two separate integrals. 2 times the integral of 1 minus, and then that's going to be 2. Remember, that 2 is for both of these integrals, so it's on both of these, minus 2 times, and then you'd have, how are we going to deal with that one? Well, I've got the e to the x over 1 plus e to the x. Well, obviously, the integral on this left is very, very simple. Right? The integral of 1 dx is just x times 2. So that's 2x. This one right here, we're going to do some u substitution. So how do we deal with the u substitution? Well, the denominator's derivative is the numerator. So if I let u equal to 1 plus e to the x, du is going to equal to the derivative of 1 plus e to the x, which is e to the x dx. Nice. So now what I've got here is I've got minus 2 times the integral of, well, here's e to the x dx, that's du, all over u. Isn't that nice? I think so too. So you've got the u value here, that's straight up natural log. That's going to be 2x minus 2 ln absolute value of u plus c. Then that's going to be 2x minus 2 ln of the absolute value of u. And then to check your answer, if you really wanted to, you could take the derivative of this, then you'd have to combine those fractions together to get back to this eventually, and that's a lot. But that's your answer right there. Isn't that sweet? Little u sub, little manipulations, beautiful. Now, if on any of these, after the manipulation part, if you're a little rusty on the integration part, check back in chapter 4 where I go over u substitution, and chapter 5 specifically with e to the x. All right, so 2 over 1 plus e to the x is the same exact problem. There's another way we could have handled this, and this is pretty nifty. I'm going to factor out the 2 again like usual. And that leaves us with, again, the 1 plus e to the x in the denominator, 1 in the numerator. But now what I'm going to do is I'm going to multiply the numerator and denominator by e to the minus x. Because what that's going to do is it's going to set us up with actually an integral that looks similar to this one. We couldn't use u substitution to start in either of these because the derivative of 1 plus e to the x is e to the x dx. And there's no e to the x dx in this problem. So another manipulation, and this time we're multiplying by 1 to get ourselves there. It's pretty cool. Right, so by multiplying by 1, we're allowed to do that. We haven't changed the problem. We get e to the minus x all over. This whole thing gets multiplied by e to the minus x. So 1 times e to the minus x, e to the minus x, e to the minus x times e to the x. Let's do that off to the side. Well, you'd add exponents, and that ends up being 1 because it's e to the 0. So that gets us plus 1. Why am I so stoked on this one? Because the derivative of this involves e to the minus x. In fact, if I let u equal to e to the minus x plus 1, du is equal to e to the stuff times the derivative of that stuff, which would be negative 1, plus 0. And that's dx. Well, we don't have a minus in there. We don't. But if I put a minus here, I've got to put a minus there to balance it out, little u substitution action. Now we've got minus e to the minus x. You've got your u, and this integral is about to get super straightforward. Negative 2, we got du right there, all over, or just u. Did you get the joke? Ooh, like you. And then you integrate that, that's negative 2 ln of the absolute value of u plus c, never forget that constant of integration, which would be negative 2 ln of the absolute value of u, e to the minus x plus 1 plus c. And you might be like, dude, Groden, those two things don't look equal. Well, believe it or not, when we simplify this thing out, and we could, you'd write this as 1 over e to the x plus 1. You could combine that in fractions and then split this thing up, use some logarithmic identities. You could get back to that. But the point being is if you differentiate this and then smush all the fractions together or just simplify it, you'll end up back at 2 over 1 plus e to the x just as you would here. So two different looking expressions that are nonetheless equivalent. Oh, it's so cool. All right, I'll see you guys in the next video. Until then, be well.